In this video, we're going to be looking at this problem, battleships in a board. We're given an m by n matrix board where each cell is either battleship X or an empty, period, and we want to return the number of battleships on the board. Battleships can only be placed horizontally or vertically on the board. They can be made of the shape 1 by k, so that's 1 row k columns, or k by 1, so that's k rows 1 column, where k can be of any size. At least one horizontal or vertical separates between two battleships, so we don't need to worry about adjacent battleships. So let's take a look at this example. There are clearly two battleships. One is a 1 by 1 and the other is a 3 by 1 vertical battleship. So we return 2. A battleship visually is a consecutive line of X's placed horizontally or vertically. And in the second example, the board is empty, so we return 0. Okay, let's break this question down. So we have a board that looks like this. So first, let's just get this out of the way. There are no adjacent battleships, so we'll never have to worry about boards like this or boards like this, and so on. So this helps because then there's no ambiguity. So for example, for this board, are there 4 1 by 1 battleships or 2 1 by 2 horizontal or 2 2 by 1 vertical battleships? So since all battleships have at least one horizontal or vertical gap in between them, we can think of this question more as how many groups of X's are there on the board. Before you jump right into trying to solve this problem, let's brainstorm some possible approaches. So the first is that we might want to try some kind of depth first search or breadth first search approach. So we would iterate through the board. Every time we see an X, we start doing a DFS or BFS on only adjacent X squares, and we can have a hash set that keeps track of which squares we've already seen so that we don't duplicate work. The second approach perhaps is that we could try thinking of the battleships as coordinates in sets. So coordinates in one set mean that they're part of one battleship, and the number of sets in the end is the number of battleships. And this would be the use case of the union find, also known as the disjoint set data structure. But these approaches are overcomplicating the problem. Instead of looking at the whole battleship, let's only look at the top left corner of any given battleship. So first you have the case where there's nothing to the immediate top or left of the battleship's top left corner, and it would look like this. Second, you have the case where there's nothing to the immediate left of the battleship's top left corner, and it would look like this. And third, you have the case where there's nothing to the immediate top of the battleship's top left corner, and it would look like this. In all cases, we can derive a rule. Every time we see an X, as long as there isn't an X to the immediate top or left, then we can count that as a battleship. So let's take a look at the pseudocode. So first we're going to have a count that starts off at 0. Then for each square, so let's say that coordinates are denoted as row, comma, column. So if the square is empty, then we're going to skip it. And then if the top square is an X, which is row minus 1 column, or if the left square is an X, which is row column minus 1, then we're going to skip it. Keep in mind, when we implement this in code, we're going to have to check for the edge cases of when row or column are out of bounds. So that is when the battleship is up along the top or the left edge of the board. And then otherwise, we can increment count because we've identified the top left corner of a distinct battleship. And then we just have to return the count. So for the time complexity, well, we're going to iterate through m rows, n columns. So the time is going to be O of m times n. And for the space complexity, we don't use any additional space, so it's going to be O of 1. Okay, let's implement this in Java. So first, let's initialize the count as 0, and then let's iterate through each row and column. If the square is empty, then we continue. And then let's check if the square directly above is an X. So note that we need to handle the edge case by excluding the first row. Then let's check if the square directly to the left is an X. Note that we also need to handle the edge case by excluding the first column. And then otherwise we can increment the count. And then we can just return it at the end. And as you can see, this solution works. So that's how you solve this problem, battleships in a board.